Hello, welcome to yet another episode where I shall be looking at the practice revision for the mathematics paper for the grade 11 in preparation for the end of year exams. Okay, so with me, I have a practice paper that I'm going to use, which is out of 150 for 3 hours. Okay, they're telling us that we have 10 questions. We need to answer all the 10 questions. All right. So if I look at the first question, okay, if I'm to look at the first question, we should be statistics. What are they saying? They're telling us that after utilizing GeoGebra to teach geometry, the 14 participants marks out of 100 are displayed in the table below. So someone got a 16, 28, 41, 41, 42, 52, and everything seems to be in order. 1.1, they're asking us to write down the mode of the data. So we know that the mode is basically the number that appears the most, okay? So in this case, the number that is appearing more than the rest of the data pieces is just a 41, okay? And then 2, identify any outlier. Any outlier is basically, or let's say outliers are basically extreme values, whether they are too high or basically too low. So when I look at the 16 is not far away from 28 because just a difference of 12. When I look at 64 and 99, that's like a 35 gap. So meaning that this 99 will definitely be an outlier. It's a very extreme mark. I mean, why would you perform better than the rest of the people like that? All right, then let's look at the median. Median, how many pieces of data do we have? We have 14, meaning that in position number 7 and in position number 8. Is that true? So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So we're going to have 55 plus 54 divided by 2. When I punch that into the calculator, I'm ending up with a 54,5. Okay, so that is our median. And then the interquartile range. So since we know that our Q2 is somewhere there in between, what is the median of the first half? So it's going to be 1, 2, 3, 1, 2, 3. So 41 becomes the Q1. Okay. And then what is our Q3? It's going to be 1, 2, 3, 1, 2, 3. So 60 is the Q3. So the median of the first half, the median of the second half will give us those quartiles, okay? But since the question is asking for the interquartile range, we need to subtract. So 60 minus a 41, which is a 19. Okay, and then they want us to draw a box and whisker. So I'll try to sketch it here. So if this is 0, we know that the highest mark is 99. Okay, let's see. So let me use intervals of 20. So 20, we have 40, we have 16, we have 18, and let's say we have 100. So if the minimum mark is a 16, okay, if that is a 10, so 16 is somewhere halfway there. We said our Q1 is a 41, just slightly after 40. And then our Q2 we found was 54,5. That is a 40, this is a 50. So roughly in the middle, somewhere there. And then the Q3, we said it is a 60. Wow. Okay, and then 99, which is somewhere there. Okay, so that is how my box and whisker would look like, okay. So having looked at this box and whisker, 1.6 is asking us to comment on the skewness of the data from the box and whisker. So you can see that there is more space between the Q1 and the Q2, okay? So this data is negatively skewed. So negatively skewed, or someone would say that it is skewed to the left. This data is skewed to the left. Okay, so that is question number 1, 10 marks in the bag. We move on to question number 2, which is also statistics, but of group data. So the weight of boxers who underwent fitness, and health checks is shown in the frequency table below. Okay, we have the weight, we have the frequency, then they want us to complete the cumulative frequency. So the first cumulative frequency will always be equal to the first frequency. Then 1 plus 3 is a 4, 4 plus 9 is a 13, plus 6 is a 19, plus 3 is a 22, and then plus 1 is a 23. Okay. And then write down the total number of boxes. So the last cumulative gives us the total number 23. And then they want us to get the estimated mean. Okay, so for us to get the estimated mean, we need to find the midpoint, okay, of these intervals. So if I have a 35 plus a 55, that gives me a 90. Divide by 2, so that's a 45. That's going to be a 65, 85, 105, 125, and then 145, okay? If I'm looking at the midpoint. Now, all I have to do is just multiply these middle points or midpoints with the frequencies. Then I will divide by the 23. So this is going to be a 45 times 1 plus a 65 times 3 plus 85 times 9 plus 105 times 6 plus 125 times 3, then 145 times 1. I'm dividing all this by the 23. Okay, so I'm getting a 93.70 as my answer. So that's how you get the estimated mean of the grouped data. And then on the grid, they want you to draw the cumulative frequency or the ogive. Let's see, I think we can squeeze it down here. Yes. Okay, so meaning that this is the weight. This is going to be our cumulative frequency. So let's start with a 5. Then we go to a 10. And then we go to a 15. Can go to 20. And probably a 25. We know that our maximum is a 23. Yeah? Then with the intervals, we have 1, 2, 3, 4, 6 intervals, okay? So 1, 2, 3, 4, 5, and probably a 6. So now I'm plotting, this is going to be my 35 here. This is going to be my 55. Okay, then 75. And then I'm going to have my 95. Is that true? Okay. 115, 135, and then 155. Okay, so when you're plotting, use the upper intervals, okay, only these ones, and then plot the cumulatives. So 55 is going to go with the 1. 1 is somewhere there. And then the next plot is supposed to be a 4. Okay, 4, then 13. So 4 is just below 5. And then 13 is somewhere there. Okay. And then 19, 22. 19 is below 20. 22 is slightly above there. And then 23 should just follow suit. So just connect this with your free hand. And then you need to set the footing to the 0 there. Oops. My footing is wrong. Okay, so that becomes our cumulative. And then they're asking us, this further given that for a boxer to qualify for the next upcoming, you must have a mass within 75 to 100. So between 75 to 100, up to somewhere there. So using the cumulative, estimate the number of boxers that will qualify for the upcoming matches. So since we know that 75 is going with a 4, okay, because that's what the table gave us. So we have 4 boxers at 75. Then we also need to look for 100. So we have 20 intervals here, one interval of 20. Okay, so if I have a 10, that's going to be 105. So roughly from somewhere there. Then I stretch that line up until it meets the cumulative and take my reading in this case. So if I'm to look at it, it's more around the 15 mark. So the difference between 15 and 4 will definitely represent the number of boxes that we need. It's going to be 15 minus 4, which becomes 11 boxes. So guys, that's just an estimated number. Ne? If you have a proper grid, you should get an answer, but still around the same value. All right, question number 3, which is the analytical geometry. They're telling us that in the diagram, P is xy, Q is negative 22, R is 2 and 3 are vertices of a triangle PQR. Line PR passes through the origin. The equation of PQ is given as this. Okay, this one is 6x plus a 14. And then S is the x-intercept of that line. First things first, they want the gradient of PR. Okay, we have P with x, y, we have R with this, but we know the origin must be a 0, 0. So what we're going to do, know that gradient is changing y over changing x. So it's going to be a 4 minus 0 over 3 minus 0. And then the gradient becomes 4 over 3. 3.2, they want the equation of PR. Since the y-intercept is a 0, meaning that the equation is going to be a 4 over 3x plus a 0. So just 4 over 3x is just enough. All right, then 3.3. Determine the coordinates of P. Determine the coordinates of P. How many marks is it? It's 4 marks. So we know that at P, that's when both graphs are meeting, the one for this equation and this graph. So what I'm going to do, I'm going to equate the two equations and say that it's 4 over 3. Okay, so 4 over 3x should be equivalent to 6x plus a 14. Let's move the 6 that side. So 4 over 3x minus 6x is equivalent to 14. When I do the subtraction, I'm getting 18, which is a negative 14 over 3x is equal to 14, meaning that our x is going to be a negative 3. Okay, then I'm going to get this negative 3 and replace it in the equation of 4 over 3 times negative 3, meaning that my y is a negative 4. Therefore, P is going to be a negative 3 and a negative 4. Okay, then 3.4, determine the coordinates of S. You know that S is the x-intercept, and then at S, y will be a 0. So from the equation, y is equal to 6x plus 14. If I replace y with a 0, and then I'll move the 6 that side, so negative 6x is equal to 14, which means it's 14 over negative 6, which is a negative 7 over 3. But since they want the coordinates, write it in coordinate form. Okay, so that is what we write, or that's how we do it in that case. Question number 4. In the diagram, A, B, C is drawn. They're telling us that we have vertices A, B, and C. P is the midpoint, okay, in the line. Q is a point on the line AC. This line is drawn on the x-axis. E is given as that. It's a point such that these two lines are parallel. Calculate the coordinates of P. So with P, we have to use the midpoint method, which is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So it's going to be a negative 7 plus 3 over 2, and then 8 plus 0 over 2. So this is going to give us a negative 4 on top, so it's a negative 2 and a 4. So that is what I will end up with, the midpoints. Okay, and then calculate the gradient of AB. So 4.2, they want the gradient of AB, so which is the change in y over change in x. So I'll say 8 minus 0 over 3 minus 7. That becomes 8 over 10, which is a 4 over 5. Okay. And then get the side theta, which is the angle of inclination. So 4.1.3, we know that m is equivalent to the tan of theta. So theta should be the shift tan of m. So shift tan of 4 over 5. What do we get from our calculator? I'm getting a 38.66 degrees. All right, then determine the equation of BC. Okay, what do we know about BC? We have the coordinates -2 and 4. We can get the gradient of BC using PE. Okay, and then we use the point P. So, okay, so it's saying the gradient of PE, this is 4.2. It's going to be 4 minus 2 over -2 minus a half. Okay, so 4 minus 2 is going to give us a 2 over, that's going to be, okay, this is going to be a plus, meaning there's going to be a -4 plus 1 over 2, which is -3 over 2, which is going to be -4 over, okay, that's what I'm thinking. So -4 over 3. So if that's the gradient, we are saying the gradient of BC, it should be the gradient of PE. And y minus y1 is equivalent to m into x minus x1. So if we replace, we have 3 and 8 as our point of interest. So y minus 8 is equivalent to -4 over 3 into x minus 3. Open that up, -4 over 3x plus a 4. And then when I move the 8, it's going to be a plus 8. So it's a -4 over 3x plus a 12. Okay, so that is how we will get that equation. And then 4.3, calculate the length of AC. Okay, so we have this coordinate. We only need the coordinates of C. But we know that C is the x-intercept where y must be a 0. So let's replace y with a 0 there. So 0 is going to be -4 over 3x plus 12. So 4 over 3x is equal to 12, cross multiply. So 4x is going to be a 36, x will be a 9. Okay. So if this is a 9, this is a 7. So it's going to be like 7 units plus 9 units, which gives us 16 units. So this becomes 16 units. Okay. And then the next question, they want us to find the area of the trapezium PBCQ. PBCQ. Okay, so there are two ways of doing this. Number one, since this distance is a 16, we have this height. The height of the big triangle is going to be 8. The distance from here up to here is what we need, because we need the coordinates of Q, that we can get the distance. And then we can also use the height of 4, get the area of this big triangle minus the area of the small triangle. But what we've also discovered was that the gradient of, no, they are not perpendicular. So we don't need to make that allegation. So what do we need? What do we need? Distance AB. Okay, we can do that, but it's not going to help me. Let me use P to find the equation of PQ so that I can get the coordinates of Q. Okay, remember we say the gradient is -4 over 3. Okay, so it's a negative. So we're using -2 and 4. So y minus 4 is equal to m into x minus minus, which is a plus. We open this up, it's going to be a negative 4 over 3x. This is going to be a negative 8 over 3 plus 4, which is giving me a 12 minus 8, which is a 4 over 3. Okay, so that is our equation. But for the y-intercept, or for the x-intercept, y is a 0. So 4 over 3x is the same as 4 over 3. This cancels that, meaning that the x is 1. Okay, so if q is at 1, okay, meaning that the distance here is basically 8 units. So let me get the area of ABC minus the area of APQ. So area of ABC minus the area of APQ. So this is going to be a half. The base is 16. The height we said is 8. This is a half. The base, remember we said this is going to be x is a 1. Okay, the base is what? The base is 8 units. And the height is going to be this 4 here. Okay, 4 units, the perpendicular height. So that is 4. Okay, so simplify this. So 16 times 4 must give us a 64. Minus this and this is a 2. So 64 minus 16. Okay, so that is 8. So we have a 48 units squared. So that is how I would have gone about that, 48 units squared. Alternatively, you can use what we call the area rule by finding the distances and things. Okay, then question number 5, the trig. Okay, so if negative 3 tan of beta minus 5 is 0 and the sine beta is less than 0, they want us to get the value of this using the aid of a diagram. So let's see, let's do it this side. Saying negative 3, the tan of beta minus root 5 is 0. Make tan beta the subject, it's going to be root 5 over 3, but this is a negative now. And then in which quadrant is the tan negative, but also the sine of beta being negative. So sine is negative and the tan is also negative. So sine is positive, tan is positive here, meaning that our target could be the last quadrant here. Okay, so in the last quadrant, we're looking at tan, which is the opposite over adjacent. So it's a negative root 5, and then this is a 3. So let's find the r, or the missing side, using the Pythagoras. That's going to be x squared plus y squared. So 3 squared plus negative root 5 squared under square root. So 9 plus 5, which gives me a 14. So this is going to be square root of 14. Okay. What does the question want? Sine squared minus cos squared. So we have sine squared beta minus the cos squared beta. So our sine is opposite, which is negative root 5 over root 14. This is squared. The cos is a 3 over root 14, but this is also squared. Simplify that, you get a 5 over 14 minus 9 over 14. So we have just the same denominators. So we're going to have a negative 4 over 14, which is a negative 2 over 7. That's what I'm getting as my final answer. All right, then 5.2. If cos 49 is a k, determine the values of following terms of k. So let's try to, do we need a sketch here? We may, okay, but it's not always a must. So cos is is adjacent, yes. So it's adjacent, which is a k. And then meaning that this side should be 1 minus k squared. Okay, so if this is a 49, then this is going to be a 41. Okay, so that we get a 90 there. All right, then they want us to get the sine of 131. So 131 is in quadrant number 2. So it's going to be the same as sine of 180 minus a 49. When you reduce this, only get a sine 49. Sine is opposite of a hypotenuse, so which means it's 1 minus k squared. And then 1 minus cos squared of 41. So 1 minus cos squared is the same as sine squared of 41. Okay, so if this is our 41, the opposite is k, the hypotenuse is 1. So that's going to be just a k over 1, which is a k, but then I have to square it, and then becomes k squared, since it is a sine squared. Okay, and then 5.3, they need us to simplify this into a single trig ratio. Okay, so reductions, we know that tan of 180 minus, this is second quadrant, tan is negative, so negative tan x. Cos negative x is the same as the cos of a positive. And then sine of 360 minus, that is in the fourth quadrant, sine is negative. But since we are squaring it, meaning that we're only going to have sine squared of x. And then the cos of 90 minus must give us a sine of x. We're dividing this by sine, oh, there's a plus sign somewhere here. Sorry, okay. Sine of 180 minus should be a sine x, okay. And then from there, your next step, is anything common? Not yet, but let's change this tan into the identity of negative sine over cos, okay? So a negative sine over cos, so this cos is going to cancel that cos, meaning that I'm only going to be left with a negative sine x plus this is sine cubed x over sine x. Let's take out the sine x. We shall be left with, why don't we take out the negative sine x so that it is 1 minus sine squared x over sine x. So this cancels that. We know that 1 minus sine squared gives us the cos squared. But since there is a negative, then we end up with a negative cos squared x. All right, then 5.4, simplify without a calculator. So if we have just numbers, then we have to use the special angles at some point if need be. So let me jot to this side. We have the sine, okay, sine of negative 15, cos of 75, plus the tan of 75, cos of 75 multiplied by the cos of 165. Okay. All right, so that is what we are having. Now, how do we break this down? Okay, so the question is, we can change, we can move this one to that side. So that's a negative sine 15. But before I look at sine 15, which value? I mean, I'm seeing just 75, 75s everywhere. So if I get a 90 minus 15, that's going to give me a 5 and 7. Okay. So let's say we have a sine of 15. And then the cos of 75 plus the tan of 75, cos of 75, multiplied by, where do we find 165? That is in the second quadrant. Okay, if I subtract from 180, that's going to give me also a 15. Okay, so let's see how we approach this question. So I'm going to say, why don't I rather change everything to 75s? So that way I have the sine of this is going to be the sine of 90 minus 75. How about that? Okay, so that this gives me cos of 75 is a cos of 75 again, plus, you know that tan 75 is the same as sine 75 over cos 75 multiplied by the cos of 75. We said this is going to give us 180 minus a 15. And if it's a cos, it's going to be a negative cos 15. Okay, negative cos 15. And if it's a negative cos 15, I know that this is going to be a 90 minus 75, which will give me now a positive. Okay, so I have a negative cos squared of 75. This cancels that. I have a sine 75. And then if I bring in a cos of this, it's going to give me a positive sine of 75. Is that true? Yes. No, there's a negative. Don't forget, because this cos, when it becomes a positive, this negative is maintained. So negative cos 75 plus, okay, it's now a minus because of the negative sign. So sine squared 75. Take out the negative, you'll be left with cos squared 75 plus sine squared 75. We know that this becomes a 1 with its negative that is outside. Okay, so that brings us to the end of 5.4. Then 5.5, they want us to prove this identity. Okay, so we have a 3 cos of x. Let's put it here. 3 cos of x. We are dividing it by the 1 plus sine x. Okay, plus 3 tan x. It should be equivalent to 3 over cos x. Okay, let's change this into sine over cos. So 3 cos of x over 1 plus sine x should be 3 sine x over cos x. This is a plus. Should be, okay. Remember, we are starting from the left-hand side, so I don't need to put the right-hand side here. Do your cross multiplication. It's going to be a 3 cos squared x. And then this 3 sine must multiply with everything here. So a 3 sine x plus a 3 sine squared x over cos x into 1 plus, I'll say sine x. Okay, so 3 cos squared x, 3 sine squared x, I'll get a 1. But since there's a 3, so I'll have just a 3 plus 3 sine x over, this is a cos x into 1 plus sine x. Take out what is common, which is the 3. That is 1 plus sine x over the cos x into 1 plus sine x. So this cancels that. And then we have that left, which is equated to the right-hand side. Okay, so that is how we would have proved that. And then 5.6, they want us to determine the general solution of this. So with this general solution, step number 1, since it's a solution that's made up of different ratios, we can create a tan. So divide through by cos squared. So over cos squared, over cos squared, over cos squared. So you're going to get a tan squared x minus 3 is equal to 0. Move the 3 that side. Tan squared x is equivalent to a 3. And then we need to find the square root on either sides, meaning that tan x should be a plus or minus root 3. Okay, so if that is the case, then we need to get the reference angle. The shift tan of root 3 gives us a 60. That's our first reference angle. That's if we're looking at the positive part. If we're looking at the negative angle, then it's going to be a negative 60. We shall see that. So if we're looking at the positive, tan is positive in the first and the third, meaning that x should be 60 plus k times 180. K is an element of integers. And then alternatively, in the third quadrant, we're going to say that okay, so we said in quadrant 3 it will be 180 minus 60, no, 180 plus 16. Okay, so it's a 240 plus k times 180. K should be an element of integers. Okay, so that becomes the last part of question number 5. And then we move on to question number 6, which is the trig functions. So we have the graph cos of x plus 30 in the interval has been drawn in the diagram below. Okay. Then can we write the period? Okay, so what is the period? Remember, the period of a cos graph is 360. Okay, so that is 360 degrees. Okay, and then we need to move on to the next one. They want us to write the range of h of x. If h of x is the same as f of x plus 60 plus 1. So what are they doing? They are shifting this graph, okay, 60 units to the left. And then they move it 1 unit upwards. Okay, what does that mean? We're going to have a cos. Where there is x, I'll replace it with x plus 60. So it's x plus 60 plus 30 and then plus 1, which becomes a cos of x plus 90 and then plus 1. So this 90 plus x gives us a negative sine x plus 1. So we know that a normal sine graph should be something of that sort. And then if it's a negative sign, it has to be the other way around. Okay, whereby the maximum is a 1, the minimum is a negative 1. Now, if you move it 1 unit up, so you're going to have this 1 move to a 2, and then this negative 1 will move to a 0. Okay, so it's a 2 and a 0. That should be our range values. Okay, 6.2. I'm going to say 0 is less or equal to y, less or equal to 2. And then simplify the equation. Okay, the equation, we've already simplified it to say negative sine x plus 1. If not, you can just look at the y values here. If you move it 1 unit up, it's going to be 2 and then a 0, and then the simplified equation is that. And they want us to draw h of x on the same grid. So with the h, what I can notice is that it's a negative sine x plus 1. So if x is negative 120, okay, I'm going to get a 1,88 something, which is somewhere there. And then if it's a negative 90, that's going to be a 1. 1 plus 1 gives me a 2. And then if it's a 60, that's going to be a negative 0,88 something, then you plus 1, which gives us this point. And then with the 30s, negative a half, or it's a negative 30, which is a half, which is 1,5. Okay, that point. And then if it is a 0, it will be a 0 plus 1, then it's a 1. Then if it's 30, it's negative a half plus 1, which is a half. If it's 60, that's a negative 0,88. Then that's going to be a 0,2 somewhere there. Okay. And then if it's a 90, 90 is going to be a negative 1 plus 1, which is a 0. And then the rising starts again. So when I connect this, I'll have this type of graph. Oops, they have to meet at this point. And then it will go up in that sort of direction. Okay, so that is what we have with our graph of h of x. And then using the graph, okay, between negative 120 and 115, for which values of x is f having a minimum value. So f is having a minimum value. The lowest value is at a positive 150. Okay, when x is 150, that's when we're having the lowest value. So we're saying x is 150. Then where do we find both graphs to be less or equal to 0? So both graphs are negative. What that means that both graphs are above or both graphs are below. So we know that h is not below. Okay, h is not below, but it's just above. So what is that going to mean? Between this 60 and the negative 120. That should be of interest. What did they say between negative 120 and that? So both graphs are, wait a minute, it's negative, né? It's less than 0, so not above. So one is positive, one is negative, or one is negative, one is positive. So the only scenario we have is where this graph of h is above and then f needs to be below. So this one is out because h is not below. Okay, so between 60 and the 150, one is below, one is above. So it's going to be 60 less or equal to x less or equal to 150. And then where do we find h to be equal to f? It's just at one point, which is the 30. So they're telling us that x should be a 30. All right, so that brings us to the end of question number 6. Number 7, the diagram VP is the same as PQ. Okay, VP is the same as PQ. And then RQS, wait a minute, RQP, okay, is the same as SPV. Okay, and then this is a beta, those two lines are parallel, this is a perpendicular. Okay, they want us to express PS, okay, in terms of alpha. So if this is the adjacent, this is the hypotenuse, we're going to use cos. So we're going to say cos of alpha is 5 over PS. So PS must be 5 over cos alpha. So that is 7.1. And then determine RB. RP, this one, in terms of alpha and beta. So if we have this value known, we have this angle as a beta, because this is the only beta we find, meaning that we need to use this triangle, PSR. Okay, we're looking for this. Do we know SR? No, we don't. But we know, okay, we know if these lines are parallel, if this is a beta, then even this angle here should be a beta. Yeah, then which means I'm going to use PQR, okay? So I'm going to say that from PQR, I apply the sine rule. I'll say that PR over the sine of alpha should be the same as PQ, which is a 5, over the sine of beta. So PR becomes 5 sine alpha over sine of beta. All right, then hence can we show that triangle RPS is equal to this, the area of RPS. Okay, so if we have the PR, we have this hypotenuse of ours, so we can get that. So we know that the area is going to be a half of PS times PR, the sine of SPR, okay, the two sides and then the angle in between. So it's a half, our PS was a 5 over cos alpha, the PR is a 5 sine alpha over sine of beta multiplied by the sine of beta, because that is the P that. All right, so let's just simplify this and see. So we know that the 5 and the 5 is going to give us a 25. This can cancel that. Okay, So 25 sine alpha over 2 cos alpha. So sine over cos gives us a tan. So 25, the tan of alpha over 2. So that brings us to the end of question number 7. Question number 8, which is the measurements. In the diagram, a lid with a hemispherical form seals an open cone. Okay. Then the slanted height is 13, the diameter is 10, the height is h. We have the formula, determine the height. So we're going to use the Pythagoras. If this is a 5, then we can use h is going to be the square root of 13 squared minus 5 squared, which becomes a 12. Okay, and then 8.2. Write down the height of the container, the entire shape. Now, since this is a hemisphere, we know that the radius 5 should also be equal to the height, which is a 5. Okay, so we have 12 plus 5, which should be 17 centimeters. And then calculate the volume of this container. So we need to get the volume of the top part. Okay, and then the volume of the bottom part. And then we add them together. So we're going to say 8.3, that 2 over 3 pi radius squared, now it's pi radius cubed, plus, that's 1 over 3 pi radius squared height. Okay, we do the substitution. So it's 2 over 3 pi, the radius we said is a 5, 1 over 3 pi, 5 squared, multiplied by the height, which is a 12. Okay, so when I punch everything into the calculator, I'm getting 575,96. And they want us to get the total surface area. Okay, so with the total surface area, we need to use the 2 pi radius plus pi r hs. Okay. So what does that give us? What does that give us? It's going to be 2 pi, the radius is 5, plus pi, the radius is 5, multiplied by the slant height, which is 13. Because remember, we're looking at this as a cone, because it's a conical shape. Okay, so having had that, substitute that into the calculator. We're getting 361,28 centimeters squared. This was centimeters cubed, because it is the volume. And the 9.1, which is the Euclidean geometry, they want us to use this to prove the theorem that tells us that. So feel free to do your construction. Okay, do the construction. Call this O1, call that O2. And then come down and tell us that O2 is going to be twice B. Angle at the center must be twice angle at the circumference. And then O1 is going to be twice of D. Same story. Angle at the center, twice angle at the circumference. But we know that if we get O1 plus O2, we get a 360. Those are angles at a point. And then we're going to get a 2B plus a 2D must be 360 divided through by 2. So B plus D should be 180. Okay. And then 9.2 in the diagram, O is the center. We have a reflex angle, which is 230. And then PQR point, circumference extended, QRT is 85. Okay, OPS is a 20. Okay, then calculate the magnitude of the following angles. They want the size of S. So we know that S is the angle at the circumference, so it needs to be a half of 230. So a half of 230 becomes 115. Reason, angle at the center is twice angle at the circumference. Okay. And then they want us to get the size of Q. Okay, so if this is 115, this is a Q. So Q must be a 65 because those are the opposite angles of a cyclic quad. And then we need to find P1. So we know that the whole of this P should be equivalent to the whole of the 85 because of the exterior angle. So I would say that P1 plus a 20 should give us 85 exterior angle of a cyclic quad. Then let's move the 20 that side, meaning that P1 should be a 65. Okay, so that becomes 9.2.3. We move on to 9.3. The diagram, we have still a cyclic quad with all of those values. We have a 130, we have a 20, and then they ask us to determine the size of P, this angle here. Okay, what do we see? So step number one, if I look at this triangle here, I see this 130 as exterior angle of a triangle, which means I can get R. So come down and say that your R is going to be 130 minus a 20. That's exterior angle of a triangle, meaning that R should be a 110. So if R is a 110, then P is going to be a 70. Opposite angles of a cyclic quad. Okay, so that is how those 4 marks would have been obtained. And then question number 10. Question number 10. The diagram O is the center. We have those lines extended. We have the perpendicular. Okay. And then P2 is a 37, it's a tangent. Okay. What is the size of O1? Okay, what is O1? So if this is a diameter, we know that the whole of this is going to be a 90. Okay. And if this is a 37, meaning that A1 must also be a 37. So start by telling us that B2 plus B3 gives us a 90 angle in a semicircle. But A1 is going to be a 37 because of the tan chord theorem. And if that is a 37, for us to get the B, what does the question want? They want O1. Yeah, we're going to get it. And so what's 90 minus 37? It's going to be a 50 what? A 53. So B3 is also a 53 because this is a radius, that's a radius, okay? So 53, 53. So O1 is going to be 180 minus twice 53. So that is 180 minus 106, which becomes a 74 degrees. Okay, so I'm getting O1 as a 74. Alternatively, we can use the angle at the center being twice the angle of the circumference. If this is 37, then multiply this by 2 to give you that angle. Okay, then prove that OACB. Okay, OACB is a cyclic quad. So what we need to do, we need to prove if this is a 90, if we can find B1 to be a 90, okay, then this shape will be a cyclic quadrilateral. That's what I'm thinking. That is what I'm thinking. Yeah, we have it. There we have it. So we said B2 plus B3 is a 90 because of the angle in a semicircle. And then B1 is automatically going to be a 90 because of adjacent supplementary angles. Okay. And since B1 is the same as O3, therefore OACB is a cyclic quad. Reason the converse of angles in the same segment. And then they want us to prove that OC okay, is parallel to PN. So when you're dealing with parallel lines, you just have to use co-interior, corresponding, alternate, and all those things. So the best, okay, will be the corresponding. I know that OPN is going to be a 90. Reason, the tangent perpendicular to the radius or perpendicular to the diameter. And then if this is a 90, this is already 90. Okay. Therefore, OC is parallel to PN, the converse of corresponding angles. Okay, so that is question number 10.1. 10.2, the diagram PET is a common tangent to the smaller as well as the larger circle. Okay, we have the diameter, the smaller diameter, the bigger diameter, and so on and so forth. It's also given that AM is P units, okay, which means the diameter here is a P. And then AS is just P minus 1. And BC is a 6. Name 3 other angles that are equal to 90. So step number 1, if this is a diameter, the angle C is a 90. Reason, angle in a semi-circle. Then we know that S1 is also going to be a 90. Same reason, angle in a semicircle. And then we can also have one of these, either A3. Yeah, it's basically A3. That is tan perpendicular to radius or tan perpendicular to the diameter. So A3, S1, and C. All right, then 10.2.2. Can we give a reason why MS, okay, is parallel to BC? So there's a 90, there's a 90. The reason is going to be converse of the corresponding angles. Okay, corresponding angles. So tell us that C is the same as S1. And then you give us the reason, corresponding angles. And then write down the ratio of AS to SC with the reason. AS to SC. Now, if these lines are parallel, okay, and we know that M is the center of the big circle, automatically S must also be a midpoint of this. So we're going to use what we call the midpoint theorem. So the ratio is going to be AS over SC is the same as 1 over 1. So AS to SC is 1:1, since this distance must be the same as that distance. The reason, midpoint theorem. All right, and then what is the length of MS? What is the length of MS? So if this is a 6, then MS must be a half of the 6. So it's going to be a half of 6, which is 3. We are still using the midpoint theorem. Okay. Then now, next, from the previous one, if let's say we're looking for a reason, besides telling us the midpoint, someone can talk about line from the center, perpendicular to the chord, must also bisect the chord, okay? Then lastly, they want us to find the value of P. We must find the value of P. All right, so what are we gonna do? Since we have a 3 here, we have a P and then a P minus 1, we can use the theorem of Pythagoras, okay? And what are we going to do there? We're going to say that our P squared should be equivalent to 3 squared plus a P minus 1 squared. Open up. That's a P squared minus 2P plus a 1. This P squared and the P squared will cancel. So 9 and 1 is a 10. So 2P is a 10, meaning that P is going to be 5 units. What does the question want? They want the length or the value of P. So P these 5 units. All right, guys, so that brings us to the end of this paper. I wish you guys all the best in your preparations and in your examinations. Okay, let's meet again when we are looking at some of the memorandums of the papers that you guys would have written. Bye-bye for now.